Hi, please take your seat, and we'd like to start this the panel. I think a lot of us are actually looking forward to this panel because this is a panel where you can actually look into the future, especially among the people who are older than 40 years old, I guess, and looking at the hot topics that are coming down the pike. Not necessarily solving today's problem immediately, but where the young, brilliant research guys' heads are. So without further ado, let me introduce each panel. I will ask each panelist to describe their hottest research project each person is engaged in. And I just want to make a point that the first, Yoonji Chen, who is working at he's a full-time professor at the Institute of Computing Technology, Chinese Academy of Science, unfortunately could not come to the panel due to the visa reasons. So we will miss him. But let me start from my furthest right. She's the only, she's the Hinshu Liu. She's a staff research scientist at Intel Corporation. Right now, she's working within Intel Movidius Group. So.
Okay, thank you, Yun Kong. Hi, everybody. My name is Huishu Liu. I'm a research scientist at Intel. And in my past 4 years, I worked at Intel Labs on emerging technologies and microarchitecture co-design, and also agile methodologies for design accelerations. And I recently moved into Intel Movidius Artificial Intelligence Group, working on machine learning accelerators.
All right, very good. Now, the second to your left is Professor Vijay Raghunathan, Professor of Electrical and Computer Engineering at Purdue University. All right.
Thank you. Good afternoon, everyone. My name is Vijay, and I'm a professor in the School of Electrical and Computer Engineering at Purdue, where I lead the Embedded Systems and IoT lab, where we're looking at a number of emerging hardware and software architectures for the design of IoT edge devices and looking at the intersection between IoT and artificial intelligence and analytics at the edge.
All right, thank you very much. Next is Robert Wille, Professor, Johannes Kepler University, Linz, Austria.
Thank you very much. Yeah, my name is Robert. Good afternoon, everybody. First of all, I would like to thank the committee, the jury, and also my nominator for this award. It's truly an honor. My main research area, actually 50% of my time I spend on design automation for conventional technologies, and the other 50% I spend on design automation for emerging technology. And this is actually where I see my hot topic right now, because we have a lot of emerging technologies coming up. Quantum computation is one, microfluidic biochip is another, optical, photonics, silicon, and stuff like that. And here we still need design automation methodologies, and this really requires different disciplines to work together. And here I see my hot topic, my hot research topic at the moment.
All right. Last but not least is Rasit Onar Topalolu, right? He's a senior hardware developer and program manager at IBM.
Hi everyone, I'm Rashid Topaloglu, and if you have noticed in the news, IBM's supercomputers have reached the top two spot in the top 500 Summit and Sierra. So I was involved in trying to bring up the yield in those supercomputers. And so this is called design for manufacturability or design technology optimization. So aside from those kind of product level work, I also try to do some research on the side. For example, recently I have some patents on improved quantum bits, and I'm serving on the Internet of Things patenting board for IBM, and I try to also link some novel areas such as machine learning to the more traditional EDA problems as well.
All right, thank you very much. As you have noticed, our guests today on the panel are the experts on really hot topics that we talk about: quantum computing, AI, and IoT. I was making a remark before this panel started. Last year, we had actually in a similar panel, we had a lot of machine learning experts. This year is the first time we had a couple of quantum computing experts on this panel, and you can see where things are going. But before we start, I just want to set the stage that I just want to get the hardest question out of the way, which is really, what is quantum computing for? Why is it needed? Let's start from there. Any takers?
Shall I start? Sure. Okay. Well, first of all, quantum computer is, I think the most important message at the beginning is a quantum computer is not replacing conventional computers as we know so far. They are expanding it, so you can, there are some sort of accelerator, and I think this is where these whole emerging technologies will go. We're going to have a much more diverse variety of computing technology, and quantum computing technology is at the moment a very promising one for many, many particular special applications. The main idea is you can exploit by exploiting quantum mechanical effects, you can actually exploit huge search spaces. You can go through huge search spaces, handle questions, and originally, many decades back, the first kind of killer application was Shor's algorithm, which helps to make a factorization much more efficient. This is still kind of the holy grail. When we solve that, we will change the entire world, but this is also one of the applications which is still the farthest away. And in recent years, particularly also with industrial participation by IBM, by Google, by Microsoft Research, also further applications are heavily considered, like simulating climate change, solving optimization problems. Quantum chemistry is a huge topic. So we still have a variety of applications where quantum computer may be beneficial. The big one, like factorization, will be still far away, but already today we have other applications where some commercial applications might be possible.
Just to add to that, I think from an outsider's perspective, I think there's a class of very hard, computationally hard problems, things like hard optimization problems and stuff, where quantum computing I think has a lot of promise, and it's also going to be the challenge in terms of quantum computing promises all of this. Look, you can compute in exponential space and all that, but how do you really extract the true benefits for a class of these really widespread, hard computational problems which are seen all over, right? Optimization problems, for example.
Okay. I'm going to get back at the quantum computing things a little bit later, because I want to see where all those different technology intersect. But my second question really is that let's get back to the, machine learning, artificial intelligence. There are a couple of experts here, and I'm just a reporter. I write about AI all the time, and I have to ask myself that, are we hyping this too much? We're not really there yet, and yet that we are putting so much, expectations and hopes for AI. So any one of you would like to take that, are we sort of overhyping AI? What do you think?
So I'm actually working on AIs in different aspects. So for the past 4 years at Intel Labs, I was looking at emerging technologies and even beyond CMOS devices. How can we revolutionize the energy scaling problems and make AI more efficient? And although I see even from the research side and also the industry side, people thinking about AI is actually a hype. There are a lot of reports about the like the multi-billion-dollar opportunities that AI can create in the market. But if you're looking at that, I will say that it's actually maybe a good thing because it actually makes the researchers and also the engineers to think about the problems and also the applications together. For example, like so AI was proposed to actually solve the data problem, right? So we want to process the data more effectively. And we all agree that AI has already revolutionized the IoT space, right? So these actually two applications can kind of like, sometimes people may say it's kind of like the couple God made in heaven, that they combine together, can solve a lot of practical problems. And even for the agriculture and also the product defect detections and also smart home devices, and also all the way from the material side all the way to the algorithm side, and also given more opportunities for proximate computing to actually dealing with different uncertainties. And these days, nowadays, people are thinking about how quantum computing and AI can be applied together to also solve like more complicated problems like the drug detections and also like the big scale financial analytics. So sometimes I think, okay, maybe there's a little bit of hype, but it actually makes the researchers and people to get more interest and looking at the different problems from different aspects.
So, I mean, my take on it is that yes and no, right?
Okay.
I say yes because, of course, you know, when you talk, there's a certain group of people, I think, who don't really understand what the AI is about. Think of AI as this magic black box, right?
Right.
You know, whatever you want to solve, give it
the world's
to a
problem.
deep neural network, and you know you'll get the magic answer, right? And of course, that's the hype part. But I think going beyond that hype, there is a lot of promise and a lot of very genuine excitement about AI technologies, and you know, AI defined more broadly, you know, a very interesting class of neuromorphic sort of computing challenges, neuromorphic engineering challenges, brain-inspired kind of computing challenges that I think are very relevant, highly relevant to industry, you know, sort of very exciting research problems to work on that I know many folks, you know, sort of many of my colleagues, for example, are sort of doing really cutting-edge work in.
I have a take on this question as well. So I'd like to maybe let a few of you know that there's this interesting thing called the hype curve, which is a kind of an idea from a company. And if you observe that curve, you will see that AI is close to the top of that curve, meaning people are currently assigning the most amount of hype to that technology. And over time, they will realize that maybe some of those things that they are thinking is not possible. For example, some colleagues might be thinking that with AI, you can be better than any other human's knowledge. But I do not believe that. For example, in each domain, I believe that a human can still remain as like the best expert because this is because of two things. So there are two types of algorithms that you would implement with artificial intelligence. One of them is where you try to feed in the classified data, and the people who classify are going to be regular people, so we will be bound by the error introduced by those people. So in the flip side, there's also this reinforcement learning where you throw the AI into an environment and it tries to learn from millions and millions of experiments. But there's a limited set of applications where you can actually support that. So you cannot, let's say, learn about certain real-world experiments like a car self-driving, because you need to prevent that it needs to not have an accident. And if it ends up having lots of accidents to learn better, then it's not a good solution. So there will be some applications that are perfect for AI, but there will be a lot of limitations, and I think these kind of things will be more apparent over time.
That's a good point. I think when laymen like myself think about AI, tend to think about general AI, but what you are talking about is narrow AI. And domain expert, AI can be only as good as your database or your data sets or your domain experts, right? So that's one thing that we shouldn't forget about that. Now, when it comes to the quantum computing, though, it seems like it's still really far away. I mean, it seems like a really research topic. Do we have today any design tools or infrastructure needed for designing quantum computer?
I would say, everybody knows Moore's law. Everybody knows the design gap and the verification gap we experience for decades in conventional computing technologies. And I think it makes absolute sense to already start developing efficient and sophisticated EDA tools for quantum computing right now, because if the quantum computing technology at some point will go to the roof, we really would have loved to actually start that right away. We have seen that in conventional technology, we are still way behind in EDA, what is possible to fabricate, what is possible to design and to verify. And I think EDA tools are really necessary right now, because once quantum computing will really become scalable, we have enough problems keeping up with this technology development.
Interesting.
Yeah, I can also maybe give my ideas on this. So we also thought about this problem at IBM. When do we need a lot of automation to design a quantum computer? And we concluded that maybe up until we have 200 qubits, maybe everything can still be done manually. I'm not going to project when we will get to 200 qubits, but I mean, you can see around that there are already 80 qubits architectures. Okay, but we also know that from academic research to a product, there's usually at least a 7-year gap. So maybe that research needs to be done so that when we need those tools in the industry, that some ideas are available to be used right away.
All right, very good. Now, I would like to move on to this, the topic of where AI and IoT meet, and also where AI and quantum computing meet. You already talked about where AI and IoT. You made it sound as though AI and IoT already married together, which I wasn't aware of. But can you please explain that? Where do you think that AI is useful to IoT, or IoT is effective in AI?
I think in the world of AI, I think data is king. He or she who has the data rules in the world of AI. And to me, the way I view IoT is it is one way of serving as the eyes and ears for gathering a lot of the data, right? That will then power a lot of the AI algorithms and the inference algorithms that make sense of all of this data. Right? And along with that, of course, come the various challenges, interesting system design challenges of really marrying the two. And I sort of liked what I heard at this morning's keynote, where I think it was Galen Hunt who said, IoT is an organizational revolution. That is powered by a technology revolution, right? So the IoT is really it's not about just gathering the data,
right,
but it's really about drawing value and useful inferences from the data. Right? And that's where I think AI really is going to provide the answers.
All right, very good.
From that point, I'm actually totally agree with Vijay, because just like he said, that the IoT is the eyes and ears, and the AI is kind of the brain. So if you kind of for us, if you want to sense the world, we see things, we hear things, and we sense things. But AI is the backend intelligence and to interpret information the data can deliver. So if you put them together, if you can realize them with energy efficient devices and circuits, and also the systems, even with algorithms at the edge, and then we can actually more effectively process the data and also even reduce the time that responds. Because of this, now we have more opportunities for example, the product defect detections, and for healthcare, and for agriculture, and it actually changed the ways that we are thinking, and it's kind of like create another growth of the like the data era.
Right.
If I may add, in case it wasn't clear from my colleagues' comments, so I have a very simple reason why AI and IoT is the perfect marriage. Because what the IoT does is, all those sensors, they keep creating data, and how AI works is it needs lots of data. So that's why the two of them, when combined, can result in very interesting applications.
All right, very good. Now, here's a question. I briefly talked about this. Where does AI and quantum computing meet? Can you explain that intersection, where the two fields intersect? Maybe Robert, no?
Well, it's a hard question, tough question, actually. I would say, I'm not sure where they exactly meet. I mean, obviously, quantum computers are not available right now, which can process huge amounts of data, right? I mean, we are very limited in quantum computers so far. My take on that is a little bit like, we have different applications for different technologies for different applications. So AI is, I mean, and both technologies are technologies to cope with complexity. We don't understand something, we use AI.
Right.
We have a huge search space, maybe quantum computing is the solution. So maybe, at the moment, this is a little bit my take. If I can kind of understand the problem from the problem formulation point of view, but suffer from complexity with respect to search spaces, for example, maybe quantum computing is the solution. If I don't really can formalize how to solve the problem right now, maybe AI is the solution. So I'm not sure if this is a matching, but maybe this is in sort of an idea of what technology to use for what purpose.
Right.
So I'll put it slightly differently, sort of, and to borrow something that Rasid said, right? He articulated why AI and IoT is sort of the perfect marriage, right? One speaks, the IoT just produces the data, and the other simply listens, which is the perfect marriage. But in this case, with quantum and AI, maybe some marriages are not meant to be. So perhaps it's best not to marry these two. But that's just a thought, right? And as Robert mentioned, they're both, I think, very useful technologies and very exciting and interesting technologies in their own right. Maybe they're really ideally suited for different applications, and they really don't need to be a commonality.
Maybe a very quick addition also, I think also, because we're looking into the future here right now, I think there won't be the single solution to all of the problems. I think there will be much more diversity in the kind of methods and technology we're going to use for certain applications. It's just totally different than it probably have been happened in the past decades, right? I mean, in the past decades we had, of course, also different kind of computing technologies, but all or most of them worked in a very similar schemes, basically with zeros and ones and with electrical circuitry. Right now we have specialized circuits, but then we also have quantum computers. We're going to have maybe DNA computers, photonic silicon. So maybe this whole thing will get more and more diverse, and I think this is where the future technologies will be in the future.
So let me maybe try to give some technical answer to this. So in the AI, there are two things we care about. One is training an AI model, and the second is using that AI model to make a prediction. Now the second part is very easy. Usually you can just do that part using a linear speed up with respect to your model. But the training part is where the complexity is. So let's say you had n training data, and each of them with a k size of training vector. Now your training complexity is kind of on the order of n squared times k. Most of the time, so depending on the AI algorithm. So this is the part that is taking a lot of time, and this is the part where people are trying to hope that the quantum computer can help. But I think for these types of problems, the speed up will not be exponential, even if we had enough number of qubits, but likely we may be able to achieve few orders, 3 or 4 times of speed up if we have the right size machine with a reasonable error control. So this is the premise that people are shooting for with that combination.
All right. Would you like to add something? Yes?
Yes, also because I'm an outsider of the quantum computing, but I think these days when we are thinking about AI, we want to solve a problem closer to the human level. But I think the good things from what I read about quantum computing is that it can solve the complex problems beyond the human level. I think maybe sometimes it's kind of like a complementary with each other, and that will solve problems into different domains. If we can divide the problems correctly for the different applications, maybe we can see a lot of opportunities inside.
Well, that's a very diplomatic answer. That's very good. All right. Now, since we are at DAC, let me ask you this. What is the role of machine learning in design automation tools? There are now, we are beginning to see that, right? AI being applied to some of the EDA tools. Can you articulate some of those examples and how useful has it been?
Some aspects of machine learning has been used in design automation for many years. For example, let's say principal component analysis. We have been using these kind of things since even late 90s, early year 2000. Now we are trying to figure out, is there alternative ways of introducing machine learning beyond what we were using it for? So most of the EDA, EDA problems usually deals with NP complete or NP hard problems, where the most efficient algorithms are still heuristic algorithms, basically algorithms that you come up with. You come up with a simplification to the problem. You try it on a few different test cases. You hope that it's going to work, and it does work to some degree. But now we are looking into ways whether with the machine learning, by just feeding more data, can we do that? So then the question becomes, how can I create more data so that I can train my model, for example? So it's a different way of thinking, and I'm still curious to see if they can beat the best heuristic type of algorithms or most efficient algorithms in each domain. So I'm both a skeptic and both hopeful about machine learning for EDA.
I'd like to think of that connection sort of the other way around, in the sense that one of the things that EDA did for design in general is that it converted what is basically a dark art into science, right? Into very structured science. And today, I think if you talk to people who who work on AI and neural networks, right, the design of some of these AI algorithms or neural networks is really a dark art, right? And one of the I think the interesting things going forward with this connect of EDA to AI or machine learning is to see if EDA can bring in that same level of rigor and structured design to the design of neural networks, the design of AI algorithms. Right? And I think that, to me, represents a really interesting connect between the world of EDA and the world of AI or ML.
Do you think, are we there yet? I mean...
I don't think so. I mean, there's some initial research which is going in this direction towards, for example, synthesis of neural networks and stuff, but by no means are we anywhere close.
All right, very good. Now, I should not forget that we do have actually IoT expert here, and let me ask you this: what's the future of self-powered electronics?
Well, if you ask me, I think the future is absolutely fantastic, because this is a topic that I've been working on for almost a decade, so absolutely best topic ever. But in sort of all seriousness, I think given the scale of devices that we're talking about, I mean, we keep hearing these 20 billion, 50 billion devices, 9 billion devices and all that. I think given the sheer scale, self-powering or figuring out some way of at least alleviating the battery challenge is going to be very, very crucial if at all we hope to scale these devices to the level at which their projections and the vision demands. And for that, I think self-powered energy harvesting devices, systems, I think absolutely are inevitable and are the way to go. Right? So I don't see it as a luxury, I see it almost as a necessity.
I actually really like Vijay's comment, given my background working on emerging devices and trying to improve the device level energy efficiencies and also design more energy efficient systems with those technologies. So as we know, the design innovations these days, they are also driving the energy efficiency breakthroughs in today's systems, right? So for self-powered IoT devices, that it also requires like the material innovations and also how to use these materials and new devices like to sustain, to have the minimum energy consumptions of the operation, per operation, and also moving data from the memory and also to the logical device. So they're actually giving us a lot of opportunities, like to create better systems, better algorithms, and also better materials to realize that type of technology.
All right. Now, since we do seem to have a really diverse panel with very different international backgrounds, and I'm kind of curious if, I'm sure that you guys are paying attention what's going on, not just in the United States, but in Asia, Europe, and so forth. Can you tell us your assessment? How do you rate progress in machine learning and quantum computing progress in each of those different, different geographical regions?
I think the bigger problem is not the geographical distribution. Research is conducting in all the world regions, and actually collaborations between the world regions, at least from what I experience, is quite good. So we're collaborating with colleagues from the US, from Asia. Of course, I'm from Europe, so of course I'm collaborating with the guys there. I think a bigger challenge is collaboration between disciplines. So actually we need to talk much more to physicists, for example, when it comes to quantum computing, or to mathematicians or people from theory. And also here at DAC, or at the design automation community, we have to do a lot of more work in order to bridge towards these communities. So I'm hijacking a little bit your question, but I don't think the problem is the geographical collaborations. My experience is this works quite okay. I think the collaboration between communities, disciplines, is much harder to establish right now.
All right. What others think?
I kind of view quantum and IoT, for example, as two endpoints of different endpoints of the spectrum, right? For example, if you look at doing something really meaningful in quantum, given how emerging it is, you really need that really true multidisciplinary collaboration. You need not only talk to physicists and mathematicians and stuff, but you also need perhaps a lot more, in order to really be a player, a lot more, I guess, capital investment. You need a lot of experimental stuff, right?
The end users, basically.
The end users, right? And the bar to entry there is basically much higher. On the other extreme for IoT, I actually view the bar to entry as being very low, right? Because you can pretty much be anywhere, and the cost of a lot of these IoT devices or IoT sensors is basically so low that there's really no limit. It's sort of almost democratized innovation to some extent, right? And you can have some really smart kid who is sort of in India or China or some other part of the world, in Europe, sort of pick up some of these components and build something fantastically innovative in terms of end usage or end application that many of us really would be astounded with, right? And so that is a part that I think, as far as IoT is concerned, it's really democratized innovation, I think, by sort of lowering the barriers for a lot of people.
So I can maybe target Robert's comments, so bringing people with different backgrounds together. And I think until we have more pervasive solutions where we can make it easy between remote people to collaborate. Let's say I sit here and then I'll be able to see one of you even though you were remotely, but in a way that it wouldn't hinder our interaction. Until we get to this stage, which we are nowhere near the stage, we have to be collocated, I think, to improve collaboration. So the way IBM is good in this approach is IBM is throwing physicists next to mathematicians and next to engineers, and they make sure that they're at the same location so that some innovation and progress can happen. Otherwise, it's going to be slow, and or people will get into silos and they will just share what they've done in each silo, but it's not going to be as good as being collocated together.
Interesting. You know, I do understand all the research and development that fundamentally global, right? But at the same time, as a researcher, you read a lot of academic papers, you know, the achievements by scholars. Do you come to any, you know, situation where, oh my God, these guys in China, for example, are so advanced. We did not think of these applications. We have not put that much resources. We have not even thought about that kind of research. Are there any examples that, oh my God kind of moment that, or are we all doing the same thing all over the world?
I mean, to me that happens all the time, that I'm reading papers and I'm thinking, oh my God, I don't understand what they're doing, but it sounds so amazing. I mean, this happened. To me, I decided for myself, I'm okay not being an expert in everything, and this is exactly also my mantra, because I'm loving doing collaborations with other people from other communities, and then whenever I do that, I also accept that I'm not supposed to understand everything what my collaborator is standing for and what's his expertise. In fact, this is the beauty of it. I have my expertise in design automation. I'm a design automation engineer by training, and that's my expertise. And when I work with people from quantum computing, they have maybe expertise in physics, and that's perfect. And I don't have to be a physicist in order to collaborate with it. All we need is we need to find an interface so that we can actually talk to each other and that we actually can complement our expertise. And that's fine. I mean, that's my approach on all these interdisciplinary topics.
I think, to me, the oh my God moment is really when we look at the amount of resources that structurally either governments or industry or corporations are basically throwing in particularly in the AI and ML space in the US compared to globally. I think there's many places, for example, in Europe, perhaps even in China, where the amount of investment that is being put into AI and sort of ML in a very structured way by the federal funding agencies or even by other consortia, I think really dwarfs the amount of funding that is being put in here in this country. And I think that is sort of my oh my God moment, that look, it's only a matter of time before some of these others just eventually reap the benefits and end up leapfrogging sort of what's going on in this country in some of those spaces.
Sure. I can maybe also comment here. So all I can say is the world is getting more competitive. So I ran into this kind of research, for example, when somebody submits an idea, let's say IoT-related idea, and then being on the patent board, I go and search if that idea exists in the open domain. And many times I find patents from China, so covering a few of the ideas, and so I'm not surprised with this, and we are never worried about that oh my God situation or anything. But yeah, I'm not surprised if people from other countries overtake you in certain areas. So what you need to do is maybe pick the areas that you want to fight and stay the best. And I think even within the United States, these maybe what were traditionally ranked, lower ranked universities, they're also trying to catch up with the higher ranked ones because now there is really little limitation on what you can learn and access to publications, and when those barriers are removed, then there's more competition.
Yeah, that's a good thing.
Want
All
to
right.
use my
Yeah.
want to use my personal experience as an example. That I remember, like when I was a graduate student, when I come to DAC, that at that time I think like there are not many. I mean, there are a lot of good works coming from non-U.S. Universities, but these days, if you can see today, like you can see a lot of like different works coming from different geographical locations, and also see a lot of exciting ideas and different perspectives of solving a problem. I think not instead of like a more frightening moment, but I'm more excited to see this.
Yeah. All right. Before I close, do you have any questions, burning questions? Anyone on the floor? To the, yeah, sure.
You want to use mine?
So I'm very excited to see the people from a very diverse background, and like the host was saying, like it's really exciting to see people from, say, the supercomputer, the experts on the IoT, the quantum computing and ED. I believe that's a specialty in algorithm and also in power efficiency devices. So all those together sound so diverse and very exciting to me. Like, what is the project in your mind that you can possibly come up with to cooperate with each other? And like as a whole, you're very young, you're very energetic. I suppose if we can come up with some very brilliant idea at this moment, at this place that you can, and also you have the expertise on your own area. You know about your area is fantastic, I know, but then there are some limitations of yours, and maybe there's something that others can help you with, and you can come up with a better, good solution for some application. So is there anything that comes up to your mind that that can be shared, and that could be the good change to cooperate with each other?
Okay, so why don't I take a stab at it? And again, I'm going to draw a little bit of inspiration from this morning's keynote about security in the context of the IoT. Right? I think that is an area where certainly I see very close collaboration required between two of these areas, at least, between IoT, of course, fundamental IoT technologies, as well as AI, because there's lots and lots of different kinds of threats which are emerging, which you will need to keep continuously analyzing, perhaps using AI algorithms to figure out if a particular attack is taking place, or if a particular IoT system is secure, or if it's under attack, and looking at data patterns, behavioral patterns, and so on and so forth. And potentially there's a role for quantum there as well, in the context of some of these security applications. What that is, it's not sort of really clear to me yet, especially given my take that this is a marriage that perhaps should not happen. But certainly between the world of IoT and AI, clearly there I see that connect, for example.
So the first thing coming into my mind, because of my background, is I really want to work on emerging technology and architecture algorithm co-optimization across AI, IoT, and probably even quantum computing. Because some of the systems, from what I read, is also using emerging devices and looking for new solutions for interconnect, and also all this, how to build the systems more effectively, or improve the temperatures that the quantum computers can be operated on. So this kind of the first project coming into my mind.
All right. Anybody else? All right, well, thank you so much. Please give applause to everybody on this panel here. Thank you very much. Thanks for your time.